Okay, hi guys. We're in BasePlayer and we're about to demonstrate how to detect somatic mutation clusters in the regulatory genome. I'm going to start by opening somatic mutations for 190 colorectal cancer samples, and they're loading now. Here they come. Loading, loading, loading. Okay. And now I think we can add a new track containing the regulatory regions by encode. With this file open. Okay, let me just squeeze this a little bit. Okay, and now I'm going to apply it by pressing play here. And now this has removed all variants outside the regulatory regions from the screen. And I'm going to hide the indels because we didn't use them in the cluster study last time, so I'm going to take them away. And now I'm setting all variant filtering thresholds as low as possible so that all low quality variants are included in the cluster as well. I've set the window size for variant clusters to 50 base pairs and set minimum mutation count in a cluster to 4. Okay, so there it is. So let's zoom into one of these clusters that appears to be coding and see what we have. Oh, okay, it's the no mutation hotspot in NRAS. So let's move on and let's zoom out and start making a list for all the clusters in the genome. So we're going to go to this variant handler and we are going to go for all chromosomes and let's start to annotate. Okay, so now let's just wait for BasePlayer to go through them all, and while we'll do that, I can introduce to you the details of the table a little bit more. So at the moment, we're looking at the gene tab where all the clusters that hit the genes are listed, and next to it, we can open the statistics tab here, where you can see variant statistics for all studied samples. We have different columns for different variant counts. You can also see separately the counts for SNVs, indels, coding, what kind of mutations they have, and in what proportions. Useful information, especially when you need to provide it for your manuscripts. And if we continue by opening the ENCODE tab, we can see from here a list of how many mutations there are and in which regulatory event. Okay, there, as you can see, seems to be quite a few already. And in the red, you can see our friend NRAS, who we encountered before. But I think I'm going to move to the clusters tab now. So if we click on here, we can have a look at it more closely. Now we can see the clusters as a list with their own ID, and we again have the variant count and its width. Variant frequency here is calculated by dividing those two numbers. So if I go over to this column and open it a little bit more, you should be able to see the genes nearby to the cluster. As you can see, intergenic clusters are colored in dark gray, intronic and UTR clusters are in the lighter gray, and coding variants such as our familiar friend the NRAS are in red. And we have the last column here. This shows the overlapping events from the applied track, which is ENCODE track in this case. And okay, so now we can go. Okay, so the calculation is almost finished and we can already start inspecting the clusters. I'm going to sort this by variant count, and now you can see it's from biggest to smallest, and I think we should go first to the mutation count with 20. And okay, we're at the location, but it seems that the cluster is caused by this repetitive sequence. So it's not so interesting, so we're going to come back. And let's go back to our list again. And I'm going to pick one that was highlighted in a paper that we're actually replicating here. And let's double click and we will be moved to the location. And now we have a dense cluster at a CTF site, and the sequence seems to be not so repetitive. If we go to our list and click on a specific sample from it, we can now zoom in and see how the aligned reads look like. And we can see how the variant calls look in the reads, but it looks good, clean. But now I'm going to open an additional track where we have binding sites for over 200 transcription factors. This file will be published alongside BasePlayer, and you can download this from the website. Okay, so now I'm going to expand this track, which shows you the visualization for the binding motifs for these transcription factors, which means now I can determine whether the mutation hits in a binding site, and here, for example, this one hits exactly in the middle of a CTCF binding site. But you know, there's so much you can still explore, but I'm going to leave that for you because I just wanted to give you a real quick demonstration. So have a go for yourself and have fun.